All right, so in example 1 and P1, we're talking about y varying directly as x. So let's start with example 1. So y varies directly as x. So the second you hear this, right, the second or you read this, right, your brain wants to immediately translate this into y equals kx, right? So that's the equation I want to use. We're told y is 10 when x is negative 2. So in part A, we're asked to write the direct variation equation. What that means is it means use this equation with a number for k, right? Because that number is going to change in every problem. So let's start with A. So we know y equals k times x, and we were given that y is 10 when x is a negative 2. Well, if I solve for k, I get negative 5 is k. So my answer to part A is y equals negative 5 times x. So there's my answer to A, right? Part B says, now use your equation to find y when x equals 8. So y equals negative 5 times 8. Y is a negative 40. Okay? And that's it, right? That's what we're going to do. So we're going to use a point that's given to find k, and then we're going to use our new equation. So P1 asks you to do the same thing. I didn't bother to write the y varies directly as x. I just was lazy and wrote like E1. So if you want to try P1 by yourself, before I do it, go ahead and pause me now. So in A, I'm going to start with that y equals kx, right? I'm going to plug in that y is 4 when x is 6. And when I divide, I think I get 2/3, right? 4/6 or 2/3 is my k. So my answer to A is going to be y equals 2/3 x. That's my answer to A, right? So B, now the trick here is I want to find x instead. So negative 12 equals 2/3 times x, right? So I'd multiply the 3 over, get negative 36 equals 2x. So I get negative 18 is my x. And that's it. All right, so let's go ahead and do another example. So we're going to go ahead and do an E2 and a P2. Right. So for E2, y varies jointly as x and z. Okay. We're going to say y equals 36 when x equals 3 and z equals negative 4. A, we're going to write that equation, right? And B, we're going to use the equation to find, we'll find y, that's fine, when we know that x is a 1 and z is a negative 2. Okay, it's a negative 2. All right, so we're going to do the same thing with a P2. So P2, same setup, right? So we're going to say like E2, it's again varying jointly. We're going to say y equals negative 100 when x equals 5 and z equals, we'll say 10. All right, and then A, I want the equation, right? And for B, we're going to use this to find z when y equals, let's do 24 and x equals 4. Okay, cool. All right, so let's walk through E2, and then you can try P2 on your own by pausing me. All right, so the first thing we have to do when we're given a statement like this is stop and think, hey, what equation does this relate to? So this is y equals kxz, right? Then I'm going to plug in y, x, and z to find k. So 36 equals k times 3 times negative 4, which is 36 equals negative 12k, right? So negative 3 seems to be my k, right? Which means my answer to A is y equals negative 3xz. And that's my equation that I can use throughout this particular problem, throughout E2. For B, I'm now going to use that equation, y equals negative 3xz, with a 1 in for x and a negative 2 in for z. So y equals negative 3 times 1 times negative 2, and I get that y is 6. So we're going to do P2. If you want to pause me and try it on your own, go ahead. I'm going to walk through it now. So same problem. It's still y varies jointly as x and z, right? Because I'm lazy and I just said it was like E2. So I'm going to use that y equals kxz again. And they don't always have to be y's and x's and z's. The constant is generally k. So negative 100, sorry, computer fell asleep. Negative 100 is k times 5 times 10. Negative 100 equals 50k. Negative 2 seems to be k. So I get y equals negative 2xz, right? Cool. So negative 2xz. Once I have that equation, I'm going to go ahead and use it. Now this time I know y and I know x, but I don't know z. So y equals negative 2xz would be 24 equals negative 2 times 4 times z. So 24 is negative 8z. Seems to me that negative 3 is my z. Cool. All right. Let's keep plugging along. All right, let's do an E3P3. So E3, P3, same situation, but we're going to say y varies inversely as the square, because I'm going to be tricky, the square of x, right? And then we're going to say that P3 is like E3. Okay, so we're going to say y equals, let's do 4 when x equals 5. A, I want that equation, right? And B, use your equation to find y when x equals, let's do we'll do negative 3. Okay, and then we're going to do the same thing over here, right? We're going to say y equals negative 3 when x equals negative 2. A, I want the equation. B, I want you to use the equation to find y when x is 10. Cool. All right, so let's walk through this. So in E3, y varies inversely as the square of x is a little bit tricky. So we know that y varies inversely as x means put x on the bottom. So the only thing the square of x means is that the equation I want to use is y equals k over, instead of x, it'll be x squared. That's the equation I want to use. So once I know that that's my equation, y equals k over x squared, now when I plug in my values, I get 4 equals k over 25, because that's what 5 squared is, so I get 100 is my k. Well, once I know that, it's easy enough to write that my answer is y is 100 divided by x squared. So there's my answer to A, right? Y equals 100 divided by x squared. Once I know that, now I'm just going to use that. Y equals 100 divided by x squared. And I'm going to plug in a negative 3. So my y is 100 divided by a positive 9. And that's it. Can't simplify it. There's no reason to make it a decimal. 100 over 9 is just fine. All right, if you want to try P3 without me, you should pause me right now. I'm going to go ahead and do P3. So in A, it's exactly the same equation. It's y equals k over x squared, right? It's just a different k. So negative 3 equals k over a positive 4, because that's what happens when you square a negative 2. So I get negative 12 is my k, meaning my equation is negative 12, y equals negative 12 over x squared, right? When I go to use that equation, y equals negative 12 over x squared, I'm going to plug in that x is 10, so I'm going to get that this is a negative 12 over a 100. You could leave it like that. That's fine, right? There are two other options, right? You could make this a negative 0.12 because hundredths are very easy fractions to deal with, right? Or if you wanted to just simplify, you could make this a negative. You can cancel a 2 out of this, right? Or I'm sorry, cancel 4 out of it. Negative 3 25ths would also be fine. Any of those answers would be okay. All right? So that's sort of the idea. Cool. All right. Last thing we're going to do before we talk about some other stuff is we'll go ahead and do one example of how to write an equation where you're talking about combined variations. So, in example 4, my bad. So we're just going to write the equation that is dictated by the sentence. Okay, so that's it. We're not gonna solve for k. We're just gonna write the equation dictated by a sentence. So in A, I'm gonna say y varies directly as x and inversely as z. In B, I'm going to say y varies jointly as x and z, and inversely as the cube of w. In C, we'll say y varies directly as the cube of x and inversely as the square root of z. Okay, so these are all combined variation, and really all I want to show you here is that the hardest part is writing out, like from the written words, translating it into an equation, okay? So remember, the key here is that the only one that goes on the bottom is if it says inversely. So y varies directly as x, so we have a kx on the top, and inversely as z means the z goes on the bottom. And that's it. And then if we were given values, we'd plug in and solve and find k, but that's all we need to know, right? Y varies jointly as x and z. Well, jointly still means goes on top, so x and z go with the k on the top. And inversely as the cube of w means a w cubed goes on the bottom, right? Lastly, y varies directly as the cube of x. Well, remember, directly is still on top, so that'll be kx cubed. And inversely as the square root of z, well, the square root of z goes on the bottom. And that's really it, okay? So I'm not going to give you a P4 that's like this. I think this kind of gets the point across. The biggest thing here is to note that of all the kinds of variation, of all the kinds of proportionality, the only one that puts the variable on the bottom is when you hear inversely. So that's it for this video. We're going to do some other examples in other videos.